So, we have been told that there is a box. Inside this box there are 1, 2, 3 red balls and 1, 2, 3, 4, 5 white balls. Then there is another box, box 2. This box has only 1, 2 red balls and again 5 white balls. Just by looking at these two boxes, we can make some statements about the probability of picking a red ball, given we know which box we're picking from randomly. So for box 1, we can say the probability that the ball is red, given we're picking from box 1, is equal to 3/8. There are 3 red balls and 8 balls in total. Similarly, for the second box, we can simply say because there are only 2 red balls and a total of 7 balls, the probability of picking a red ball is 2/7. The question has also told us that the probability of picking from box 1 is equal to the probability of picking from box 2, which means that the probability for each one is a half, as there are only 2 boxes, and probabilities sum to 1. Now, what we want to find out is, if we have randomly selected a ball, and we know it happens to be red, what is the probability it came from box 1? So, another way to rephrase this question mathematically would be to ask, what is the probability that the box is equal to 1, given that ball is red? Just as a quick reminder, because this will be a useful tool throughout this question, is of Bayes' rule. You have probably come across it before, but just as a reminder, the probability of A given B is equal to the probability of B given A times the probability of A, all divided by probability of B. So, the thing we're trying to work out is for boxes and balls. So if we let A equal the box and B equal the ball, we can say our original setup can be converted into a Bayes' rule format, where we can say the probability of the box equaling 1, given the ball is equal to R, is quite equivalent to the probability that the box is equal to 1, times the probability of the ball being red, given the box is equal to 1, over the probability that the ball is equal to red. As you can see, we now know all the values in the numerator, but the denominator is a bit confusing. How do we know what the probability of a ball being red in general is? Well, we can demarginalize this. If you remember the definition of a marginal, we know that for any variable x, the probability of x, and we selected some other variable y, can be written as the summation of the joint probability of x and y, where the summation is always over the second variable y. This makes sense intuitively as well. If we are iterating over every possible joint probability with the other variable, we are essentially having only the original distribution, probability of x. In this case, we can apply the marginal to the probability the ball is equal to r. And that gives us this denominator. So the probability that the ball is equal to r is the probability that the box is equal to 1 times the probability the ball is equal to r times given the box is equal to 1 plus the probability the box is equal to 2 times the probability the ball is equal to r given the box is equal to 2. And this makes intuitive sense. We can get the ball is equal to red either by going into box 1 or by going into box 2, and we know the given probabilities in either case. Now, every single term in this fraction is known, so we can simply sub them out. And that is half for the probability box is equal to 1, also half for the probability the box is equal to 2. And the given probabilities, as we have stated before, is 3/8 for box 1 and 2/7 for box 2. And voila, we have an answer of 21/37, which is approximately equal to 0.57. And that is that.